Hi, I'm Dr. Christopher Sutton, and welcome back to my Introduction to GIS video series. In this video, we will examine direction. Direction is a foundational concept in GIS, guiding us to understand how and where things move and connect in geographic space. Direction is the course along which something or someone moves, or is aimed or pointed. In order to determine direction, a reference point from which direction will be measured needs to be established. In this video, we'll discuss two types of direction: geographic direction and magnetic direction. There is a third, grid direction, used in mapping that will not be covered here. Before we get into how direction is used in GIS, it's important to establish a baseline on how we define and refer to directions. We have the cardinal directions. Cardinal directions are north, south, west, and east. Halfway between the cardinal directions are the intercardinal directions. These are northwest, northeast, southwest, and southeast. Halfway between the intercardinal directions and the cardinal directions are the secondary intercardinal directions. These include north by northwest, south by southeast, and so on. Geographic direction is determined relative to Earth's axis of rotation. There are two key reference points in geographic direction, and these are where the axis of rotation intersect Earth's surface. In the northern hemisphere, we have the geographic North Pole, also referred to as true north. In the southern hemisphere, we have the geographic South Pole, or true south. These 2 points are exactly opposite each other on Earth. The term given to when points are diametrically opposite each other on either a circle or a sphere is antipode. Thus, the geographic North Pole is the antipode of the geographic South Pole. Why is geographic direction important in GIS? Well, there are a handful of reasons. The first is that direction provides a standard reference framework. Geographic direction ensures consistency when mapping and analyzing spatial data. All map projections, coordinate systems, and spatial analyses rely on true geographic direction as a baseline. In navigation and routing, direction is essential for creating accurate routes for transportation, logistics, and navigation systems. With respect to movement, direction supports studies of migratory patterns, ocean currents, and wind flows by identifying the directional paths of movement. And with respect to spatial orientation, direction facilitates the proper alignment of geographic features when combining data sets from different sources. Magnetic direction is defined by Earth's magnetic field. The magnetic poles are the points on Earth's surface where the planet's magnetic fields converge. Earth's magnetic field is not aligned perfectly with Earth's rotational axis. Thus, the magnetic poles are not in the same location as the geographic poles. Earth's magnetic field moves over time. As a matter of fact, over long periods of time, the magnetic field can flip. Where are the magnetic poles relative to the geographic poles? Let's look at the North Magnetic Pole. This map shows the migration of the North Magnetic Pole between 1900 and 2024. Also shown on this map is the geographic North Pole. You can see that the magnetic pole has been moving across the Arctic Ocean, and at no point was the magnetic North Pole located in the same position as the geographic North Pole. A term related to geographic and magnetic direction is magnetic declination. This is the angle between the magnetic pole and the geographic pole, and it varies depending on the location from which you are measuring. Magnetic declination is important to know when using a magnetic compass. Why is understanding magnetic direction important in GIS? In field surveys and data collection, in the absence of GPS, fieldwork often relies on magnetic compasses for directional measurements, which must be corrected to align with true geographic directions. Many localized navigation systems, especially in areas without access to digital tools, use magnetic direction for orientation. The good news about magnetic direction measurements is that GIS allows for the correction of magnetic declination to ensure alignment of spatial data. What kinds of applications might we see direction being an important part of what we do in GIS? In navigation and routing, GIS combines direction with distance to create optimal routes for vehicles, ships, and airplanes, ensuring efficient travel and logistics. Directional information enables turn-by-turn navigation for real-time applications like GPS. We use direction in movement and flow analysis. Direction is critical in analyzing the movement of objects or phenomena such as wildlife migration paths, river flows, ocean currents, and wind patterns, or the spread of disease or invasive species. In mapping and visualization, direction provides orientation in map design, ensuring maps are intuitive and aligned with real-world geography. We can use directional arrows and vectors in maps to represent flows, such as traffic movement, trade routes, or disaster evacuation plans. In emergency management, direction is vital in predicting and modeling the paths of hurricanes, wildfires, and other natural hazards, allowing GIS to inform emergency response strategies. In cultural and historical studies, direction plays a role in reconstructing historical trade routes like the Silk Road, or understanding the directional alignment of cultural or religious sites. Direction is more than just north, south, west, and east. It is vital in GIS to help us understand movement and connections in geographic space. In the next video, we will continue our introduction to core geographical concepts by examining spatial relationships and patterns.